on Tuesday, there was a question on your Google form where I said, imagine you have this banding pattern for a melanogenin, right? This means that you have the XY chromosome. The Y chromosome contains a slightly longer version of the melanogenin gene compared to the X chromosome. So when you run this through, when you do PCR, and then you run this through a gel, you get this banding pattern, right? So this is me. And then, and let's say I'm a suspect. And then this is the crime scene melanogenin banding pattern. Oof. And the lawyers, the prosecution tries to argue that, the banding patterns match. This is strong evidence that the suspect was at the crime scene. I'm going to say, wait a minute. Like half the population has this banding pattern, right? So what I'm going to argue is that the fact that my banding pattern matches the crime scene banding pattern is purely a coincidence. And a lot of people selected at random from the general population would have the same banding pattern as the crime scene banding pattern. So it's ridiculous to argue that this is evidence against me, right? And so this is kind of the scenario that you're looking at here in the Drew Dracula case study. It's like, okay, well, true. There are a lot of people who have the same banding pattern as the crime scene banding pattern who have nothing to do with the crime. So let's look at some of the other short tandem repeats. Like, for example, let's look at THO1. So the crime scene THO1 genotype was 5'7". Me, my THO1 genotype is also 5'7", right? The 5 just means, I think THO1 is TCAT, I think. Regardless, it repeats, TCAT repeats 5 times on one chromosome and 7 times on the other, right? And same for me. Okay, the TPOX crime scene genotype was 8 repeats, 9 repeats, and it is for me as well. The CSF, 11 repeats, 12 repeats at the crime scene, same for me. Oh boy, right? So now, if I want to argue that I'm innocent and this is purely coincidental, we can actually calculate the probability of selecting an individual at random from the population who happens to have the crime scene genotype just by coincidence. So we need to look at what is the frequency of the alleles in the general population. So you can see here allele number 5. 5 repeats is not very common. It's pretty rare. Right? So 1/200 is the frequency. And then allele 7, 1/6. So 1/1200 is the probability of someone being selected at random having 5'7". Almost. We're not quite there. Because think about it. You can be 5'7" 2 ways. Just like you can be big A, little a 2 ways. There's 2 ways to be heterozygous. You can be 5'7" because you get 5 from mom and 7 from dad. You can be 5'7" because you get 7 from mom and 5 from dad. Right? So there's actually 2 ways to be 5'7". At the end of the day, that doesn't change the fact that the 7 frequency is 1/6 and the 5 frequency is 1/200. Whoops, 1/200. But you can be 5'7" this way or this way. Right? So this is coming back to our Unit 5 multiplication or addition rules, right? These are mutually exclusive events. So because of that, we're going to add the probabilities together. So we get 2/1200, which is 1/600, right? So the probability of selecting an individual at random from the general population who just happens to have a 5'7" is 1/600. All right. Once you find that probability, you then multiply it by the probability of also being 8, 9, and you multiply it by the probability of also being 11, 12, right? And so hopefully you can see if we get some matching STR banding patterns, the probability, as more and more and more and more match, the probability of that match being a coincidence becomes astronomically small. And the other argument, which is it's a match because it's your DNA, becomes much, much, much stronger, right? There are, and this last I checked, there are approximately 20 STR locations that we look at, right? So this is only looking at 3. Imagine matching for all 20, right? Doesn't matter how good of an attorney, well, maybe it does matter. It does matter because it's happened. But it's going to take a really good attorney and a really gullible jury to be convinced that that was not your DNA, right? Now, I mean, the argument is well, just because my DNA was at the crime scene doesn't mean I committed the crime, right? Maybe I was there like the day before the crime. So there's multiple ways to spin it, but the point is that we use this to identify individuals, right? Because well, yeah, let's just leave it at that. We can use it to identify individuals, whether we're talking about forensic identification, whether we're talking about paternity, looking at paternity. And so that's what you're doing in today's activity.